Okay, now we're going to learn about factoring with some special techniques. Okay, so 5.4 is factoring with special techniques. Okay, and the first one that we're going to learn is factoring the difference of two squares. So think about something squared: x squared, y squared, 2 squared, 3 squared, or it could be 9. 3 squared is 9, 2 squared is 4. So those are what you call squares, or perfect squares. Okay? So basically the format, if we look at x squared minus y squared, okay, this can be factored as x plus y times x minus y. So if you notice here, we have the difference because there's a negative sign, and it's the difference of what? Well, it's two squares, x squared and then y squared, and then it's the difference. And this is how it factors: x plus y, x minus y. Okay, so let's say I had something like 25t squared minus 16. Okay, well, we could rewrite this, all right, as, well, first of all, let me say that you should notice that 25 is a perfect square. So just over here on the side, what are perfect squares? Well, 1, 4, 9, 16, 25, and so on. So this is like 1 squared, this is 2 squared, this is 3 squared, this is 4 squared, this is 5 squared, and it just keeps going, right? So you should notice that 25 is a perfect square, so we can write this as 5 raised to the second power, and then we have our t squared, which is t squared, subtract, and then 16 is a perfect square. We can write that as 4 squared, right? So since both of these are raised to the second power, we could actually write this as 5t and then raised to the second power. That's using one of our exponent laws. So if you squared the 5, you'd get 25. If you squared the t, you get t squared. So this 5t squared, okay, this right here, is the same as this right here. Okay? Then subtract 4 squared. So this is in the form of x squared minus y squared, right? The x is actually the 5t, and the y is the 4, okay? So this factors too, okay? 5t plus 4, 5t minus 4, all right? So notice that I put the 5t here, and then the 4 here, and it's separated by a plus sign, and then the 5t and the 4, and it's separated by a minus sign. Okay, here's one a little bit easier. Let's just look at like t squared minus 9. Okay, well, you'd have to recognize that 9 is actually a perfect square, so this is the same as t squared minus 3 squared. Okay, and you don't have to rewrite it like this. If you notice that 9 is a perfect square, then you can just directly go to, well, that's just going to be t plus 3 and t minus 3. Okay? Let's look at another one. Let's say we have 100 a squared subtract 81. Well, you should recognize that 100 is a perfect square. Another way to do it is, can you take the square root of 100 and get an integer value? Yes, the square root of 100 is 10, so that means 100 is a perfect square. Okay, so again, you could directly go and write this as 10a plus 9 and 10a minus 9. Okay? Because again, 81 is a perfect square. Right? That's just 9 squared, right? Now if you didn't recognize this, try to break it down. So I'll do it this way. We can write this as 10 squared and then a squared, subtract, and then 9 squared. And if we simplify this further, well, 10 squared and a squared is just 10a, and then that's raised to the second power, and then subtract 9 squared. So then we can write this as our two binomials here, and it's just going to be the 10a here and then here, so it's 10a, whoops, rewrite this, 10a and then 10a, and then of course this will be a plus and this will be a minus, right? And then it's just going to be, this value goes here, 9, and then it goes here as well. So 10a plus 9, 10a minus 9. All right? How about this one? A little bit more complicated. X to the 8th subtract 16. Okay? Well, anytime you have an excuse me, an exponent raised to an even power, or sorry, a base or a variable raised to an even power, I should have, not an exponent, but a base raised to an even power. This is the even power. It's always going to be a perfect square. Okay? So we also know that 16 is a perfect square. So what happens? Well, we know that it factors to what? Well, you're just going to take half of that exponent, the 8th power. So it'll be x to the 4th, x to the 4th. Okay? And then it'll be plus 4 and then minus 4. And you can always check yourself. Don't forget you could do that. If I use the distributive law, in other words, multiply this times this times this, and then this times this, and this times this, okay, you'll see that you'll get x to the 8th minus 16. All right? Now, I'm not done with this yet, because notice right here, we also have the difference of two squares again. This is an even exponent, okay? So we can take half of that, that's x squared, and then we also know that 4 is also a perfect square. So we'd have to take this to the next line and write this as x to the 4th plus 4, okay? Should make this look more like an exponent. So x to the 4th plus 4, and then this of course is the difference of two squares, so it is written like x squared and then plus 2 and then x squared minus 2. And then that's it. Okay? So every once in a while you might think that you're done, but you actually end up with something like this where you can actually factor it again. Okay? Let's do another problem here that throws some people off. So let's say that I have 3x to the 4th minus 27. And you might say, well, x to the 4th is a perfect square, but 3 isn't, and then 27 definitely isn't a perfect square. But remember what I said, always try to factor out a common factor first. And the common factor here is a 3, so we can take out a 3. So it's 3 times x to the 4th, subtract 9, because 9 times 3 is 27. Now this right here is the difference of two squares. X to the 4th is a perfect square because this power is even. And then 9 is perfect square, right? 9 is just 3 squared. So we could write this as 3 times the binomial of x squared plus 3, x squared minus 3. All right? Here's one with a fraction. This throws people off sometimes. So c squared minus 1/4. You might think, that doesn't look like the difference of two squares, but it actually is, because we could write this as c squared minus 1/2 to the second power, because what's 1 squared? Well, it's 1, and what's 2 squared? Well, it's 4. So 1/2 squared is actually 1/4. So notice this is the difference of 2 squares, because there's our even powers right there. So this just factors to two binomials, c and a c, and a plus 1/2 and a minus 1/2. And if you multiplied this out using the distributive law, you would end up getting this back. So always check your result. It just doesn't hurt to do that, because then you can verify whether your answer is correct or not. Okay? Now, one thing that, well, let me just do one more. M to the 4th, n to the 4th, minus r squared, s squared. Excuse me. Well, this is definitely the difference of 2 squares. Okay, we have even powers here and even powers here. So let's combine them together. So this equals mn to the 4th power, right? Subtract rs to what power? Well, the 2nd power. And is all that I'm doing is I'm kind of undoing this rule. AB to the nth power is a to the n, b to the n. And I'm just kind of going backwards. You're given this, which is right here and right here, and then I'm just writing it in this form, which is down here is what I'm doing. Okay? Now, this is definitely the difference of 2 squares. Okay? So, guess what? This factors to 2 binomials. So it's just the first one goes here, mn, and it goes here, mn. Right? And then this rs goes here, and the rs goes here. But it's a plus and then a minus. And then you're done. Okay? Now, what have I been saying? The difference. And what does difference mean? It means to subtract. You have never heard me say the sum of 2 squares. So, a squared plus b squared does not factor. It is prime. Okay? So you cannot factor the sum of 2 squares. Some of you guys will try to go a plus b times a plus b, and that is incorrect. It does not equal to a squared plus b squared. Okay? Do not try to factor the sum of 2 squares. Let me say it again. Do not try to factor the sum of 2 squares. Let me say it again. Do not factor the sum of 2 squares. Okay? It is not factorable. All right? Okay, so practice that. It's a pretty easy concept. Difference of 2 squares. X squared minus y squared is simply x plus y, x minus y. And then I did just a lot of different variations of problems. Okay? All right, so the next thing that I'm going to teach you, which is a special product, and that is a perfect square trinomial. Okay, perfect square trinomial. All right, basically what that is, okay, if you have a binomial like x plus y squared. Remember we did this already. Remember there was a way to do this? A quick way. Remember, let's try to do this. Remember, you square the first, x squared. Multiply the 2 terms together, the inside terms here, you get xy, and then you double it, so times 2, and there's a plus there. And then you square the last one is y, so it's y squared. Okay? And let's do it for the subtract, x minus y squared. So x minus y squared is simply going to be squared. And if you forget, remember, if you forget this pattern, you just do x plus y times x plus y and use your distributive law and you'll get this. Okay? So if we square the first, it's x squared. Multiply these two inside together, you get xy. But then you double it, and then this, because there's a subtraction sign here, you put the subtraction sign here. Okay? And then you square the last. Well, of course, a negative value squared is going to be positive, so it's going to be positive y squared. Okay? Now, what these two things are called, right here, this result and this result, these are called perfect square trinomials. Alright? Now how would you might think, well, that's great. It's a perfect square trinomial. It looks like a bunch of craziness there, right? How am I supposed to recognize that? Well, it's very simple. So this applies to both of them here. So let's say I look at this, and let's look at some characteristics. If I take the square root of y squared, what do I get? I get y. Alright? And what if I take the square root of x squared? So in other words, I'm taking the square root of the first term, and I'm taking the square root of the last term. Right? So the square root of x squared is x. The square root of y squared is y. So now I have an x and a y. Right? Excuse me. And then you just multiply these two together. Well, multiply x and y, you get xy. And then if I double it, so now double this, so double the product, you have to put a 2 in front of it, and that's like doubling. Well, check this out. This 2xy is right here, and it's right here. Well, the only difference is the sign. Okay, and that will just come out when you start working with it. So to tell when you have a trinomial, 3 terms, whether or not it's a perfect square trinomial, take the square root of the last term, or start out by taking the square root of the first term, see if it's a perfect square. Take the square root of the last term, see if it's a perfect square. Multiply them together, and then double it, and you should get your middle term. Okay? So let's check this out. We'll actually do it. All right? So let's say I have p squared plus 4p plus 4. All right? Now, let me just do the technique real quick. If I take the square root of 4, I get 2. If I take the square root of p squared, I get p. If I multiply p times 2, I get 2p. If I double 2p, in other words, multiply it by 2, I get 4p. Ah, look, there's my 4p. Okay? So we know this is a perfect square trinomial. So what does it factor to? Well, it factors to a binomial, right? So let's look back up here. Look at the one with all pluses on it. So I took the square root of y squared, I get y. I took the square root of x squared, I get x. I multiply x times y, I get xy. I double it, I get 2xy. So what happens then? Well, it actually factors to the square root of the first term, the square root of the second term, put parentheses around it, and square it. So let's do it over here. This goes here, 2. This p goes here, and then you just use the sign, it's plus. And then you put your square on it, and you're done. That's a perfect square trinomial factored right here. Okay? Now every once in a while, and I do the same thing, sometimes I don't even notice that it's a perfect square trinomial. I'm just kind of working through things so fast, and I go right into that table. Remember when we used this table method? When we were factoring ax squared plus bx plus c, and a was equal to 1, remember? We put the c value down, which is 4, and then we put the sum of all the products of 4. Well, this is 4 and 1 and 2 and 2. Well, what's 4 plus 1 is 5. What's 2 plus 2 is 4. Okay? And there we have the 4, which is our middle term, 4p. So this just factors to the two binomials, and we use these values, 2 and then 2, and of course it's going to be a p. Whoops, I'm sorry. What am I doing here? Besides confusing you. The 2 and the 2, so we know it's going to be p, right? So here's p and p. I meant to put the 2's over here, so we put a 2 here and a 2 here. And then p plus 2 times p plus 2 simplifies, because it's the same base, to just p plus 2 to the second power. And that's what we have over here. Check it out. P plus 2 to the second power. So my whole point is, if you don't recognize it right away as a perfect square trinomial, of course it's faster to factor it if you notice it's a perfect square trinomial, but if you don't, and you automatically go in and using the table, you're still going to get the same result. But don't leave your answer in this form. You want it in its more simplified form, which is this one right here. It's more compact. Okay? So let's do another one. Let's go with this one here. 16x squared minus 40x plus 25. So I would just check this real quick. Well, what's the square root of 25? Well, that's just 5, so that's good. What's the square root of 16x squared? Well, that's actually equal to 4x. So I'm going to multiply these two together. So 4x and 5x is 20x. And remember, I have to double it. So multiply by 2. And this is 40x. Well, this here is the same as the 40x there. So that's great. We know that this then is a perfect square trinomial. Put our square there, and it just factors to, well, the square root of the first term, which is 4x, square root of the second term, which is 5, and then we put this sign, which is next to the middle term, which is a negative, okay, or a subtraction symbol. So 4x subtract 5 squared. All right. Now, just as a review, I'm going to say, hey, what if you were on a test or you were in another class or something and you were trying to do a problem and you were asked to factor this and you didn't recognize that it was a perfect square trinomial? Well, you'd have to go through our table method again, where a x squared plus bx plus c, and a is not equal to 1. So remember that we had to put down the 16 and the 25, and then because the middle term happens to be negative, then the 25 will need to be the product of two negatives. So negative 25, negative 1, negative 5, negative 5. And then 16 will just be 16 and 1, 1 and 16. Remember, we reverse the order. 8 and 2, 2 and 8, and 4 and 4, right? Okay? So remember, we have to multiply the first, so let's just look at this one. So we have to multiply the first with the first, so that's 16 times minus 25, and then add that to the second times the second, 1 times minus 1. Well, there's no way that that's going to give us negative 40, right? Because 16 times 25 is a big number. So let's go to some smaller ones. We'll try this one here. Let's try 16 times, so if I do this one and then this one, 16 times minus 5, no, that's going to be way too big. That's minus 80, and then added to minus 5, no. Okay, let's do some smaller ones here. Let's look at these two right here. So I'll actually write this out. So let's try 2 times minus 5 plus 8 times minus 5. So that's minus 10 plus minus 40. Nope, that's minus 50. We're getting closer, but we want minus 40. It looks like, I think this is going to work. These two, actually. So, let's check it out. 4 times minus 5 plus, and then 4 times minus 5. That's minus 20 plus minus 20, which is minus 40, and that's our middle term. So these are the ones we're going to use. So then we would write our two binomials. So we'd write our 4x, okay? That's from the first two numbers we got, the 4 and the 4. And of course, the only other two are they're the same numbers, so it doesn't matter where you put them. So minus 5 and minus 5, okay? But notice these are exactly the same, so you'd write in more compact form, which is 4x minus 5 squared. And there we go. We have the same result. Whoops. Click on here. There's our result that we had, 4x minus 5 squared. And here's our 4x minus 5 squared. So the last resort, you could use the table, which you've already learned how to do, if you don't recognize it's a perfect square trinomial. Of course, when you start doing the homework in this section, you know, there'll be ones that are perfect square trinomials because they want you to practice. All right? Let's do another one. Let's say we have 2x squared plus 24x plus 72. Again, I'm looking at this, and right away I can see that there's a common factor of 2. 2 could be taken out of each of those coefficients. So I'm going to rewrite this as 2 times x squared plus 12, because 12 times 2 is 24x, plus 36, because 36 times 2 is 72. Now, if I look at this right here, this trinomial, is it a perfect square trinomial? Well, let's see. What's the square root of 36? That's 6. What's the square root of x squared? That's x. Let's multiply 6 times x. That's 6x. Let's double it. Means we're multiplying it by 2. And we get 12x. Okay. So, whoops. Hang on, I do this right here. Yeah. Yep, we're good. I was looking at the 24 up there. I'm sorry, I forgot I factored it. So here's the 12x and the 12x right here. So we're good. So we know that is a perfect square trinomial. So this just factors to 2 times, and then in parentheses, the x, and then the 6, right? That comes from here and here. And then since it's a plus sign goes inside, and then of course we have to square it. So our result, let's just make it a little neater, it's 2 times x plus 6 squared. Now, if you needed to check yourself or wanted to check yourself, in fact, let's do it. So let's put down here check. All right. So that's 2 times, well, we have to do the squaring first. So remember, you square the first, x squared. Multiply the x times 6 together, you get 6x, double it, you get 12x. Square the 6, you get 36. Alright? And then let's multiply this out. 2x squared plus 24x plus 72. And guess what? Let's go up a little bit. This here is the same as this here. So we know he did it correctly. Alright? So I would recommend you guys checking yourself, because it'll be guaranteed on a test that you get it right. Okay, and your homework, you know, you can be a little bit more relaxed about it, because if you input it, you know, it tells you your answer is wrong, and then you get to do it over again. But on a test, you don't. So I would definitely check your work. All right? So then the last thing that we're going to learn out of a special product is going to be the sum and difference of 2 cubes. Simply stated, the sum of 2 cubes, x cubed plus y cubed, and the difference of 2 cubes, x cubed minus y cubed. Okay? So it's almost like the difference of 2 squares. Okay? Remember, we couldn't factor the sum of 2 squares, but we could factor the sum and the difference of cubes. Okay? So, thing to notice though, a cube added to a cube and a cube subtracted from a cube. Alright? So what is this factor to? Alright, well, how I remember this, the first thing is going to be a binomial, and it's just going to be these same variables. So it's going to be an x and a y. And then this sign will be exactly the same. So it'll be a plus. Okay? Then it's going to be multiplied by a trinomial. Alright? So how I remember then the way it's going to go, it's going to always be, of course, this variable x, but you have to get it to the third power. So this has to be squared, right? Because if you use the distributive law, x times x squared is x cubed, right? And then the last one, okay, has to be a y, and then that's going to be squared because eventually you're going to multiply the y times y squared and you get y cubed, okay? But then the signs alternate. So notice that the sign here is really a plus x squared, and then you're going to alternate to a minus, okay? And it's going to be a minus the product of these two right here. So xy. And of course it's plus. So notice you go plus, and then minus, and then plus. So the signs alternate. Okay? It's going to be almost exactly the same for the difference of two cubes. Okay? It's going to be x and a y, except now this sign is minus, so the minus goes there. Alright? And then we have a trinomial. It's going to be x squared, it's going to be y squared. And the only difference now is that it's going to be a plus. The signs are exactly the same. So x squared plus xy plus y squared. Okay? So this is just something you have to memorize, just like some of the other things. Alright? Just get familiar with it. Alright? So let's practice this. So let's go ahead and factor, let's say m cubed subtract 8. You might look at it and you go, that doesn't look like, is 8 a perfect cube? Yeah, because you can write 8 as m cubed, and then 8 is going to be 2 cubed. Okay, because 2 times 2 is 4, 4 times 2 is 8. And here we have the difference of 2 cubes. So remember, that's going to be the binomial. So it's going to be an m and a 2. And the minus sign goes here. Right? Then we have a trinomial, so it's going to be an m squared. And it's going to be 2 squared. Okay? And then remember, the negative and the m minus 2 means that these are all going to be positive. So it's going to be a positive, and then the 2 times the m, right? So, write 2m, and then our plus there. Okay, and that follows exactly the same pattern. So if you look at this pattern here, for this, it's exactly the same thing that I did right here. Okay? So the only thing that I'll finish up, though, you don't want to leave it as 2 squared. You leave it as m minus 2, m squared plus 2m, and then 4. Okay? Write it like that. All right, let's try another one. Let's say we have 81 x cubed plus 3. Well, we have an x cubed. Okay, that's a perfect cube. 81, let's see, is that a perfect cubed? Well, 2 times 2 is 4. 4 times 2 is 8. No. 3 times 3 is 9. 9 times 3 is 27. No. Oh, wait a minute. I see something that I told you that you're supposed to do all the time. Factor out a common factor, and guess what? 3 is a common factor. So some of you might have already seen it. So I can take out a 3. Always do that. Makes your problems a lot easier. Okay, let's see. So 3 times 27 is actually 81, and that's going to be x cubed, and then plus 1. Ah, yes, makes things a lot easier. And I definitely recognize that this is the sum of 2 cubes. Why? Well, 3 cubed is actually 27. And there's my x cubed. And then 1 is just 1 cubed. So you can make it into a cube. Okay. So let's rewrite this again. This is 3 times, and then we'll use 3x. I'll put a color here. So that's raised to the 3rd power. And then plus 1 cubed. Okay? So basically a 3x and a 1. Okay? So 3x cubed plus 1 cubed. So there's the sum of 2 cubes. So let's factor that. So this is just going to be 3. Okay? And then it's going to be 3x plus 1, right? Plus sign there. The 3x here. The 1 here. Okay? Then you multiply it by, well, the 3x needs to be squared. The 1 needs to be squared. Now remember the signs alternate. It goes plus, minus, and then a plus 1, or 1 squared. So it's minus what? Well, you just take the product of these two values, 3x and 1, or 3x times 1, is just going to be 3x. Okay, so let's say here, this was from 3x times 1. Alright, so let's finish this up. Be 3 times 3x plus 1 times, what's 3x raised to the 2nd power? That's 9x squared. Then subtract, subtract 3x, and then 1 squared is just 1. Okay? And there we go. That's in factored form. Okay? So key thing here is notice that I had to factor out a 3 first. And once I did that, then I noticed that we do have the sum of 2 cubes in 27 cubed, or 27x cubed plus 1. Okay? Let's try, let's try another one. How about 125 t cubed plus 8s cubed? Well, there's the cube and there's the cube. So the question is 125 and 8 perfect cubes? Yes, they actually are, because 125 is 5 cubed. Alright, 5 times 5 times 5. So there we have t cubed. And then 8 we know is 2 cubed. And then we have s cubed. So we can rewrite this as 5t to the 3rd power plus 2s to the 3rd power. Okay. Then this equals, okay, this is the sum of 2 cubes. So remember, our 5t, our 2s, and then the plus sign here. And then we have the 5t to the 2nd power. And then we have to subtract. 5t times 2s is 10ts, right? We just multiplied these two together. Alright. And then the 2s will be plus, right? 2s. Let me erase that. It should be 2s to the 2nd power. So plus 2s to the 2nd power, and then close that bracket there. Alright, so let's simplify this a little further. So this is just 5t plus 2s, and then 25t squared minus 10ts plus 4s squared. Okay? And that's it. Okay, one more. Let's try x to the 9th minus y to the 9th. Well, these are definitely going to be the difference of cubes, but you might not see it. This one's a little tricky. Okay, you have to go back to this exponent law that a to the n raised to the m is a to the nm. Okay, so the question is, how do I make this into the difference of two cubes? So we have to do a little manipulation. Well, I know that 3 times 3 is 9, so this is going to be x cubed raised to the 3rd power. Alright? Subtract y cubed, and then that's going to be raised to the 3rd power. So we actually see it is the difference of two cubes. Alright? So, what does this factor to? Alright. Well, we have our binomial. So we have our x cubed goes here. Then we have our y cubed goes here. And our negative sign goes here. Right? And we have our trinomial. So it'll be x cubed. So it's the first one, and then you raise it to the 2nd power. And then the y cubed, erase this, the y cubed, the last one, and then raised to the 2nd power. Right? And it's always going to be plus now because it's x minus, so it'll be plus, plus, plus. So plus, you multiply these two together. So it's x cubed times y cubed is x cubed, y cubed. So there's all of our plus signs. Alright, so let's simplify this. So this is x cubed minus y cubed. And this is x to the 6th plus x cubed y cubed plus y to the 6th. Now if you inputted this into your computer, it would mark you wrong. You might say, why? It looks like it's right. Well, notice here you actually have the difference of two cubes again. So we need to factor that. So this is just x minus y times then x squared plus xy plus y squared. Okay, so that's this right here factors to this. Right? And then, of course, we have to rewrite this down here. So it's times x to the 6th plus x cubed y cubed plus y to the 6th. And that would be our final result. Okay? Alright, so that's the last problem there. Practice, practice, practice. So we have learned in this section how to factor the difference of two squares. And I said only the difference of two squares. The sum of two squares cannot be factored. Okay? So the difference of two squares, a perfect square trinomial, and the sum and difference of two cubes. So we've learned how to factor this. We've learned how to factor a perfect square trinomial. Whoops. There are two forms of that. Okay. And there's this one. Okay. And this factors to x squared. Oh, sorry. This factors to x plus y, x minus y. This factors to x plus y squared. This factors to x minus y squared. And then, of course, we just did the difference of two cubes, which is x minus y times x squared minus xy, plus xy plus y squared. So remember, when this is minus, these will all be pluses. And then x cubed plus y cubed, so the sum of two cubes, so it's x plus y. So again, this minus matches with this one, this plus matches with this. So now we know there's going to be an alternating sign, so x squared minus xy plus y squared. Okay, so those are all the forms that we learned. So like I said, just practice these, and you'll have a chance to do it on your homework. And then the next section is going to be solving quadratic equations. But before I finish up here, let's talk about a strategy for factoring real quick, because we're kind of wrapping up our factoring. So let me see here. I think I have something written down for you guys. Find it. I don't know where I wrote it down. Oh yeah, here we go. So let's look at a factoring strategy. Okay, so first thing is always try to factor out a greatest common factor, which what do we call the GCF? Okay, always look for that first. Okay, then look for how many terms are in the polynomial. Okay, how many terms are in the polynomial? All right, well, let's break this down. If there's 4 terms, try factoring by grouping. So that should be a clue. 4 terms, use grouping. Remember, you group the first 2 terms and the second 2 terms. Okay? If it's going to be 2 terms, basically there's a possibility that it's the special factoring techniques we just learned. So 2 terms, try factoring, or well, I should say, not try yet. You want to see, so 2 terms, difference of 2 squares. Okay, just talked about that. Or it could be sum or difference of 2 cubes, right? All right. Then, what about 3 terms? Well, for 3 terms, the special possibility or special product would be a perfect square trinomial. Okay. It could also be, or it could be ax squared plus bx plus c, a equals 1, or a is not equal to 1. And remember, we used our tables for that. So if it was a is equal to 1, you'd put the c value, then the sum of the products, and then here, if a was not equal to 1, you'd use your a and c, and then use the table on that, right? If nothing can be factored, then So I'll put down here, nothing can be factored, then the polynomial is prime. Okay? Every once in a while you have a prime, polynomial. And then we just make a note here, running out of room, is always check your result using any technique or just basically the distributive law. Okay? So that's kind of the strategy. Main thing you guys always look for, and it's sometimes easily forgotten. Whoops. Down here. Always look for the GCF first. That's very, very important. Okay? Alright, so that ends this section on special factoring techniques in 5.4. So the next thing we're going to do is we're actually going to take all of these different polynomials that we've been dealing with and set them equal to either 0 or some constant and try to solve that equation. And we're going to use the factoring strategies to solve that equation. So the next sections actually should be very easy once you have down all of these factoring techniques. Okay?